DonorsChoose.org. If you guys don't know, we're a Kickstarter for education. We are in over 60% of public schools in the US, $250 million in classroom supplies that we've delivered to schools. And the way it works is pretty simple. Qualify teachers, post project on the website. It's an all or nothing proposition. So the project gets funded or it fails. If the project gets funded, then the procurement order triggers with the vendors like Amazon, Best Buy, a bunch of other folks. And they deliver those classroom supplies to the doorstep of the classroom, right? So there's never money, the money is never getting exchanged between you, the backer, and the beneficiary. And we think it's really cool because it's like ultimate transparency. Every cent is accounted for. It's right there on the website. You know what's going on. So we really pride ourselves on that. But another thing we pride ourselves on is if you give money to a project in a classroom, you get this from students. How rad is that? So, you know, you get handwritten thank you notes because of the impact that you've made. Everything from biology kits to pencils and pens and art supplies to museum visits. It all comes to life with over 20,000 projects live at any point in time, with a success rate that topples Kickstarter and a lot of other crowdfunding platforms at about 75 to 80%. All right, so we have all of this great data, and we have data on what teachers are needing in the classroom and what they're innovating with, like 3D printers and underwater robots. But now that we have all this data, how do we answer our questions? And our questions relate to marketing, standard marketing questions, donor retention, email campaign optimization, A/B testing, feature analytics, inventory prediction, reporting. Like Lincoln was saying, you know, we had all the same struggles, cron jobs and, you know, and custom SQLs, and that was my life before Looker. But underneath Looker, we have the following setup. Whoa. What we really love about Looker is that we don't do any ETL anymore, and we don't have to do any ETL. For the most part. So our app lives on Postgres, bottom left corner. So what we do is we actually just copy and paste our database into Redshift through S3. That's what people do. You know, they load stuff on S3 and then they load it into Redshift. So nothing new there. But we did write a script which we open source, link on the next page, which will get you up and running from Postgres to Redshift migration within like 1 hour. You can probably hook it up to MySQL by adjusting a few regex commands. But what it's doing is it's inferring your constraint structure, your indices and your other constraints, and ports them over sort keys to Redshift. If you're not familiar with that, it's essentially like indices, but in Redshift lingo. So our model, by doing essentially no ETL and just dumping out dirty data from our transactional database into Redshift, is shit well optimized. Like, it's incredible. It runs super fast in Redshift. We did no optimization, no custom coding, just a little Python script that does the magic. Of course, there is Zendesk customer service data, heap data, event data. Those come as JSON, you know, DynamoDB load, pipeline into Redshift. I haven't detailed that process because we're still trying to figure out how to best massage that. So there's some ETL with JSON stuff that you have to flatten. But when it comes to transactional data, easy, lovely, and we offload all of the ETL to Looker. One other thing is that I'm a data scientist, right? So one thing that I want to use Looker for is to build models, be it prediction models, classification models, or just like a hard analytical question that has nothing to do with machine learning that you know, you kind of need a language for that's beyond SQL or procedural SQL, which Redshift doesn't support anyhow. So, you know, I use Python mostly. Lots of people use Scala or R. Other things. So, you know, we heavily use Looker API to get the data out in our Python as a data object, massage it. For example, donor gender is an easy classification problem. You look at the patterns in the first name compared to the census. You label it as male or female, and you put that column in a separate persistent schema in Redshift, a schema that doesn't get refreshed all the time with all your new data. It's like the schema that all the prediction algorithms dump data in on their own schedule. So it's kind of off the regular cron tab Unix command sort of scheduling. And it's there, and then Looker knows about it. So that's our data stack for the most part. When we migrated to Redshift, Lloyd told me that I was going to get 100x improvement. So, you know, I have two queries here 2 seconds on Redshift, 60 seconds in database, pretty beefy Postgres instance. We got 30x, we didn't get 100, but I think it's because our data is not huge. Like, we have 100 gigs of data. Yeah, we have some tables that are tens of millions of rows, but they're not billions. So I bet if your guys if your guys' data is way bigger, you're probably gonna get up to that 100. And Lloyd did not only disappoint, like he proved our job to be, our performance to be incredible because it's consistent, right? So with Redshift, you're getting consistent performance. Look at this, 195 seconds for that query on the left. That's insane. So if you're sitting there in Looker waiting for 195 seconds, you're thinking, what? Like to Lincoln's point, you start distrusting the tool. You think something's wrong, and that latency is just unacceptable. Anyhow, that's the link to the open source code. Check it out. All of the ETL is kind of done inside Looker. Persistent-derived tables. How many of you guys use persistent-derived tables? Probably everybody who uses Looker. And I'm going to be talking about inventory prediction and how we forecast our inventory over time. It's 3 different persistent-derived tables that are linked together. They're dependent on each other and on related triggers. They're compounded derived tables. And you can see right here, inventory project by date, .SQL table name. That's a compounded derived table that Looker understands, glues the tables together. Sums of different stuff, subselects, basically the stuff that you'd roll up, calculate all your stats in the ETL process, and nicely put them in your data warehouse. No longer needs to be done. You just do it in Looker. Looker does the load and the transform. From this perspective, so that's something that really, really helps our workflow. I'm glad Lloyd talked about symmetric aggregates because I want to give you an example of how it's completely transformed modeling without going too much into language. So I'm going to skip this slide. Aside from saying we did the same calculation, $33 million in 1 month with a regular sum, $4,300,000 with a symmetric aggregate sum. That's the right number. That's the right number. $4 million is like what we made in the last month for students across the US. Pretty awesome. Oh yeah, and it's like relationship one to many. How cool is that? 1 line on the bottom of that slide. That's all I had to do. User experience is really critical. I think there's an impact of symmetric aggregates that goes way beyond code. So the before things that we had to train our staff in understanding this, the fundamental question of what view do you go to get your stuff, right? And it's not really trivial. And then once you get into a certain view, especially if you're trying to learn, you build this look, you're so proud of it, but then you want to add one more freaking column, and you can't because it's another view. So you pull up another tab and you build a totally new look, and then you download both of them as 2 Excel spreadsheets, and then you're back into the Microsoft land. And there couldn't be a worse experience than that. So the fact that Looker solved the SQL challenge it's not just like Looker challenge, it's a linguistic challenge, and it's a challenge of the entire business intelligence community. We were able to do this, collapse them in sensible base views that are very simple. So when you go to revenue, now you can correlate revenue to crazy things like event data. And beyond having a great experience, what's under the hood is way smarter joins, code reusability, far less coding, far fewer repetitions. So before, we had to join donors on donations. So there were donors who made donations, and there were donors who created accounts who didn't donate. 2 different views. You have to analyze them separately. And just on and on and on, we had all these views. But afterwards, we joined everything to donors. Just make it easy. Have a good time. Have a beer. Donations, we joined donations to donors, event data, favorite data, comments that they've made, like emails, all of our email data, so we can figure out revenue by referral and different email campaigns, and how that relates to look at that ugly thing, cart items, what sort of items you ordered consequently, and it's just allowing us to do a lot more. So, we use the new calculations, Looker's new feature, to figure out whether handwritten thank you notes, remember I showed you a slide with those beautiful notes, whether they have a anecdotal, not a controlled experiment, a correlated, sort of correlative impact on donors' lifetime value. So if you are qualified, if you're qualified for those, and if you're elected to receive them versus you reject those thank you notes, if you have the experience of handwritten thank you notes, is your lifetime value higher or not? So we're trying to control for the fact that you qualify for the experience. You just opted out of it. So we control for that. So it's the same donor type, the donor who gives more money on the average. So we controlled for that. And we found out with this beautiful calculation that would before require exporting the look into Excel by dividing 2 columns with a really nice syntax, that there's a 50% difference between donor lifetime value over the 2 years on the average between one group versus the other. So if you've experienced handwritten thinking notes, great. We did this, and you know who did this? Our donor appreciation manager, right? Person on the operations team who manages the whole team of about 10 people. She did this in Looker, and she discovered calculations. We did not market that feature, and I loved people trickling in and saying how they just found, awesomeness. So aside from that, I wanted to show you how we correlated Optimizely event. We had a real quick, simple Optimizely test to see whether one variant of a pitch works better than the other. Optimizely said, yeah, they're statistically significant. One is better than the other. And you just got to believe it and take it on the face value. And this is what our product and marketing team struggles with, because their follow-up question is like, well, which donor segment best responds to this test? And secondly, what's the actual project cost, average project cost for one group versus the other? What's the actual dollar difference of this significant test? And you can do it in Looker. This is a very tiny difference of 679 minus 658. Right? I mean, what is that, 21? Really small difference. But that sort of insight is critical in a follow-up, right? You can have statistical significance, but lack of importance from a business perspective. And this drives decision-making for feature development and all sorts of priorities for a product team. Again, Looker shines there. And it's a cool integration of event data with kind of your transactional database setup. All right, let's go back. One thing that we've really appreciated too is just the power for reporting. One of the things that our operations team did in the past with all of our vendors, I mentioned Best Buy, Amazon, others, is giving them public URLs to giant looks, right? And then they would download that data as CSV. Now before Looker, obviously they had to download all that data from SQL and send them an Excel spreadsheet. A very cumbersome, difficult process. So we tried to eliminate all of those steps. We gave a login to a partner to self-report. So here's what it looks like. A partner logs in, and they see nothing but their own dashboard. They don't get any access to other data. There's pretty strict controls over that. We actually took this out of the regular model and put in a separate model altogether, just to be so certain that nobody screws up permissions in the future, and they get to see or drill in other people's data. So this is a live dashboard. We're still trying to figure out what's best for Amazon and what they want to see. I'm not going to go into too much detail, but I think something that's really important to them is just straight up old school reporting, and that is downloading this giant table of data. So they click here and they click download, and it takes about 10 minutes to train them how to use it, and then our operations team is free and can finally utilize their 5-week vacation with unlimited personal days. So next, we're also hiring. Another thing that we do, I mentioned data science. This is where we pull data out of Looker through an API, worked on it in R and Python, and put it back. What this is an inventory count on multiple days in the past. Oh, there it is. So the question is this: what would it take dollar-wise to wipe out the entire website on a certain day in the past? So let's just look at 2014. 30. Oh no, that's not dollars. $21 million. That's what it would take to do it on November 26th of 2014. 2013. Those are fiscal years. And look, this year the growth has been staggering, 41 million, right? So it's a huge jump. So we're trying to figure out, looking into the future, if we want to run a campaign with Sonic or somebody else, and they want to target a specific geography, now you got to appreciate this. There's all these filters. You can segment this graph and this prediction by all sorts of filters. This is the biggest table we've ever built. It's 100 million rows. I know it's not big by some of you guys' standards. Actually, our event data is way bigger, and it's 10 terabyte. But I don't consider that. I'm talking about specifically this attribute data or transactional data. So then, we've built this giant table, and then you can filter by it, and it uses all those derived tables. I showed one. There's 3 of them. They're compounded. They're depending on each other, and we get this. We get this smooth regression line that does deseasonality and controls for all sorts of spikes. And make sure that it stays in a state of control and does a regression line on the residuals, and basically builds this beautiful prediction curve in light blue for 2016. So years stacked on top of each other, right? You have 13, 14, 15. 2016 is coming up, our fiscal year. So you can actually plan for a campaign in a specific geography. The coolest thing is that this prediction in Looker responds to the filters that you set. So if you're looking at Cleveland, Ohio, right? Okay. Then this curve is going to look completely different based on our market activity there in the past 3 years. So these are some of the things that we're doing with Looker, and results like these are really cross-departmental. And going back to this concept of culture, data culture in the organization, what you can actually accomplish with data is get different teams working together. So we built this for a partnership team to do funding. But our customer relations team, customer service team approached us saying, wow, we can kind of predict the volume of support tickets and seeing how we have to increase our flex force. Thank you note team came up to us and said, holy shit, we gotta scale up. We're gonna see this big influx of notes 3 months from now. So we gotta figure out how to handle that. It's kind of cool. Today I walked by a conference room and I just peeked in, and here it was. It was like a Looker screenshot. And somebody was convincing somebody to do something. That's all I want. That's all I want. All I want is get my data into Python and learn scikit-learn and do crazy stuff. Nobody understands that. I don't even understand. And I want people to figure out the rest for themselves. And I think Looker has been great at getting there without us having to do any ETL babysitting or cron tab management. So yeah, thank you.